In the world of electronics, every one of you encounters a microprocessor in some way every single day of your life. Let's take, for instance, the phone that you're using at the moment to watch this video on. Inside there's a microprocessor that handles all of the tasks and applications and tells your phone what to do. How does your phone know when you click that button that it has to open an app? This is all programming that's been programmed onto the microcontroller to tell it what to do in certain conditions. And that's exactly what we're looking to achieve with an Arduino. In a very similar way, but this is just a much more basic version than what you'll find in phones and all of those fancy things. But on the more low end, you do find similar controllers to the Arduino in alarm systems, car parking sensors. It all depends on the complexity of the application, but everyone has to start somewhere. And I think the best place to start is going to be right here. The controlling board, simply all of these components has been added in a sense to add extra functionality to the board and to make it easier for you to use. So imagine you had to go and solder on all of these little components surrounding the microprocessor. That's going to be quite a hassle. So they've already done it for you, made it easy for you to program and easy for you to use, but in more professional applications you wouldn't be using your board like this. You'd rather be using the chip and adding these to your own circuit board that you have designed. But this is a great starting point in learning how to get to programming microcontrollers and how to actually use it in a functional way and to build your own cool projects. So let's have a look at the microcontroller underneath the camera and we'll go through all of the components that it consists of. This is the Arduino Uno, so we're going to be having a look at what all of these components do. It does look like quite the symphony of components, and it does look very intimidating and very confusing. But it's actually simple once you get to know these components individually. Let's get a sketch here that makes a little bit more sense. So I have this one for you guys here. Here we go. So here we can see that everything has been marked out. So I can just place our board over here. And there we go. We have quite a few like little guidelines here that's going to show us exactly what's going on. So over here we have our digital pins. Don't worry if you're not certain what digital pins and analog pins are yet. We're going to get to that in just a moment. So first off, we have our little indicator LED. You can see there's a little L there. So whenever our board uses the onboard LED to make sure that our program is working, we're going to be using that LED right there. We also have a power LED. Now this LED turns on whenever power is applied to the board, and that's mostly the LEDs that you're going to be using on board. When there is communication between your computer and your chip, these two LEDs are going to turn on as well. So a good indicator to see if your program is actually being uploaded. Then over here we have these rails. Now these rails are used to insert sensor pins or whichever wiring you'd like to add to the board. It makes it nice and easy so you don't have to solder anything on. These are just header pins that you just plug in straight into the board, and we'll have a look at that in just a moment. Over here we have a reset button. You press this whenever you want your program that you've uploaded to your Arduino. If you wanted to start over from scratch, you press that button and it resets the Arduino. It's basically like turning something on and off very fast. Over here we have this little yellow thing. Now this does look like a resistor, and indeed it is, but this is a thermal resistor, so it acts as a resettable fuse. So whenever you have accidentally connected your board in the wrong way, or you're pulling too much current, this thing actually heats up and its resistance increases up to a point where it doesn't allow current to flow anymore, protecting your board against mistakes that you accidentally make. Over here we have our USB jack. This is where we plug in our USB cable. I can demonstrate that in just a moment. So here we go. This is where you plug in your USB cable. This cable can be used to supply your Arduino with power from your computer, but also it's used as a way of communicating data from your computer to your Arduino. Remember, we have to write a program and tell it exactly what to do, and that's what we're going to be using. Over here, we have a DC jack input. Now, most power supplies comes with a DC jack input, but there's something special about this DC jack. As you can see right next to this, like this little chip. Now, this is known as a voltage regulator. So what happens if you plug 12 volts into an Arduino that actually operates on 5 volts? It's gonna explode, most probably. So what they've done here is they've added this DC jack with a little regulator here on board. Now this regulator is going to regulate the voltage that you put in here up to a maximum of 12 volts down to 5 volts for you to use. So this is very useful whenever you want to supply your Arduino with power from, let's say, your car battery or so. You're going to use the DC jack and give it power through this board. Through the voltage regulator, which will supply power to your chip, which happens automatically. Then at our next other side, we have a few power pins here. Now this is used to supply your pins with power. So you see we have a 5 volt, 3.3 volt, ground, and a V-in. Now the V-in is connected to the input voltage of the Arduino. This will mostly be 5 volts, but it's connected directly to the input voltage line. Then over here we have our analog pins. Now analog pins are used for reading stuff like voltages, etc. But we'll have a look at that in just a moment. So just know that these that says A next to them are your analog I/O pins. Then over here, this big black chip you guys see here, this is actually the heart of our Arduino. This is actually the Arduino. All of these other components that's been added is just for ease of use and application to make it easier for you guys to understand and use, so you don't have to go and solder all of these other components on. But this is our Arduino. This is the Atmel Atmega328, and this is what all of our programs. This is where all of our programs gets uploaded to, and this is where the magic happens. All of these pins that you see here on the side, they are brought out into these pins through resistors and through the necessary lights and components. So this just makes it much easier for you to use this board as a whole. And over here, we can see a little diode there. Now this diode is also quite important as it allows us to protect against reverse polarity. So if you accidentally add 5 volts to ground and ground to 5 volts, it will not blow your chip immediately. This thing is going to get very hot. So the reason for that is it blocks current flow in the opposite direction. So this is a very nice little reverse polarity protection that's been added in there for you. Now the last thing I wanted to get to was this little black chip over here. Now this is very important. So imagine your computer speaking in a language. Let's call it English. My computer speaks in English and my Arduino speaks in Afrikaans. They can't understand each other if they speak to each other directly. That's why we have this little black chip in here. This is basically a language compiler. So what it does is it, think of it at the moment as a translator. So whenever it receives English from the computer, it translates it to Afrikaans in a language that the microprocessor can understand and can process whatever we're telling it to do. Also, in the reverse section, your controller can't speak directly to your computer, so it speaks to this chip in Afrikaans and it translates it to English and therefore speaking to your computer. So if you wanted to know what the real names are, microprocessors use serial, whereas the computer uses the USB protocol, and therefore we need this little black chip just to tell it what to say to each other. But you don't have to worry about this because this happens automatically whenever you program your board. But yeah, that's basically everything in a nutshell, all of the most important components that you'll use on the board. And next we're going to be having a look at analog and digital pins, what they do, and I'm also going to be running through a bit of applications surrounding how you will power your board, what works, what doesn't work, and a few nitty-gritty tips and tricks. So let's get into that.